All right, here we go. A few just kind of definition and ideas to go through here. And so we've got standard position. And standard position is when we have our unit circle with its center at the origin. And specifically, we're talking about an angle, then the vertex at the origin. Or sorry, the array, I suppose is probably a better way to say that. Um, and so our initial ray, when it's in standard position, is heading out to the right along the x-axis. This is the initial ray. Initial ray, where it's starting from, and along the positive x-axis. And you'll be measuring always counterclockwise. So counterclockwise. And we've talked about that a little bit in the last few videos, but just to be more explicit about it, that's going to be positive angle measures. So positive number of degrees or positive number of radians. That'll move around the circle in a counterclockwise direction. On the other hand, if you're going clockwise, that's because you got a negative degree angle. So or maybe a better way to say is when you have a negative degree angle, then you will go clockwise, which is that direction. In case you're not super familiar with a traditional analog clock. So there's clockwise. That's going to be when you have your negative angle measures. Now, if you got an initial ray, we'll also have what's called a terminal ray. That's where you end up after going the certain measure of degrees. So you started here, and for example, we may have gone a positive number of degrees that way, counterclockwise, or it's also possibly went a negative number of degrees clockwise. And so this would be negative degrees if we're going clockwise, and this over here is going to be positive degrees if we're going counterclockwise. Okay. Now, when your terminal ray ends right along one of your axes, along the x or y axis, it's called a quadrantal angle. So if that's going to happen, when would you, starting from your initial ray here, where would you have a terminal ray that ended on either 90, 180, 270, or back at 360? Well, if you think back to your unit circle, so let's look back up there. Those are multiples of 90 degrees, so 90, 180, 270, 360. Or if you're looking at the radians, it's pi divided by 2. So pi divided by 2, multiply that by 2 gives you pi. Multiply that by 3, and it gives you 3 pi divided by 2. And multiply that by 4, and you're back to 2 pi, which is the circumference of the circle, which is the complete degrees or radians of the circle. Okay, so when is it a terminal ray? It's when the terminal ray of the angle lies on an axis. Whether it's X or Y doesn't make a difference, but that's when it's a quadrantal angle. So you're going to have that when your angle measures are, or when your angle measure is a multiple of 90 degrees or pi divided by 2 radians. Remember, these are really equivalent. 90 degrees is pi divided by 2 radians. And so you'll have that when they're landing right on your axes. All right, and last piece, coterminal angles. This is, actually we have a good picture of it up here at the, right here. Come look at this picture up here. And it's when you have two angles with the same terminal ray. So for example, this one, maybe that positive angle was at, let's say, 135 degrees. And these are just examples. So an example would be 135 degrees. So this one could be, it's gone more than 90, but it's not 180. It's over to here. And that would be positive 135 degrees. And the other way, if we'd gone negative 225. those would both get us exactly to this terminal ray, whether we went positive, and so counterclockwise, or negative, so clockwise. Those would be an example of coterminal rays. Coterminal. All right. Hope that helped.